Acharya here. In this video, I'll do the homework from section 7.2, the application of the normal distribution. Question number 1, find the area of the said region under the standard normal curve. This is the standard normal curve because of this line represents the z-score. Therefore, this is the standard normal curve, and you got to find the area here between these two numbers. You can see that negative 2.19 and 0. Okay, remember that 0 is a mean for standard normal curve. Here mean is going to be 0 and the standard deviation is going to be 1. Okay, for standard normal curve, mean is always 0, standard deviation is 1, and you try to find the area of that shaded region. Okay, and say use the technology. Therefore, here we use a calculator. When you find the area, you got to round it to 4 decimal places. See the instruction here. Okay, to find the area, you use normal CDF function. Okay, normal CDF, and we use lower bound. I write LB for lower bound, I write UB for upper bound, I write mean, and I write standard deviation ST. Therefore, these 4 numbers together in normal CDFs gives you this area. Again, is LB for lower bound, UB for upper bound for the area, the mean for the standard normal curve, standard deviation for the standard normal curve. If you put this all 4 numbers together in the calculator, you get the area. In this case, look at this area here. This area bounded between negative 2.19 and 0. Therefore, this number here is going to be lower bound. Always smaller number is going to be lower bound. This is the lower bound. A lower bound I call LB. That's why I said here. And this, for this area, this number is called upper bound. Okay, upper bound. Makes sense? And use this upper bound and lower bound to find the area. And you have to put the calculator. Let me put that in the calculator. That's the calculator. And how do you find normal CDF function? You have to do second and VARS, and you see that number 2 is normal CDF, and you type number 2 or scroll down to number 2, it doesn't matter. This is highlighted and press enter, and you see the normal CDF parenthesis starts, and you put the lower bound, and you guys see the lower bound here is negative 2.19, negative here 2.19, comma, upper bound is 0. This is the 0 upper bound for this area, 0, comma, mean gonna be 0 again, because that's the mean again. For standard normal curve, mean is always 0. I put 0, comma, standard deviation is 1. I put the 1, and I close the parenthesis again because it's here, and close parenthesis, and if I enter, you get this number 0.4857, and remember that rounded to 4 decimal gives you 0.4857. So this area going to be 0.4857. Okay, that's the area when you round it to 4 decimal places. Okay, some of the calculator had this kind of option. They give you lower, upper, mu, and sigma. Remember that the mu is mean. This the mean. Third number is mean, and sigma is standard deviation. And you guys, if you have a calculator that shows that type of window, put the lower bound as this number, put upper bound as this number 0, mean as 0 here, again standard deviation as 1, and paste it and enter, you get the same answer. Make sense? Alright, question number 2. Okay, use technology to find the indicated area under standard normal curve. Again, you notice that this curve here is standard normal curve. As long as you see that Z score on this line, that's called standard normal curve. And for standard normal curve, mu gonna be 0, sigma gonna be 1 always. That's the mean, that's the standard deviation for standard normal curve. Okay, part A says find the probability that Z score will be 0.17 or less. Here find the probability. I want to tell you probability is same as area. Therefore here basically looking for probability, we are basically looking for area under this standard normal curve to the left of 0.17. Well, let's find which area represent 0.17 or less. Let's see. Of course, look at this. 0 is somewhere here. 0.17 is slightly on the right, correct? Remember that 0, but pretty much this looks like the same points here. But remember that 0.17 is to the right of 0. Therefore, this is the right answer. A is a correct graph you choose first. Okay, make sense? Therefore, here this line is z-score. Okay, we just call z if you like, just the z, and therefore this curve is called standard normal curve. And this curve, so area on the left of z-score 0.17, because it says 0.17 or less, has to be this way. Okay, make sense? Now to find the probability, you got to find the area, and to find the area you need lower bound, upper bound, mean, and standard deviation. Remember that. That's how you find the area using normal CDF. And for this graph, what do you guys think? Which is the upper bound, which is the lower bound? That's the answer for of course part A. And to find the probability, you're looking for area. This area is what? That's what I'm looking for. And to find the area, you got to find upper bound and lower bound, right? Of course, mean and standard deviation is here. 0 is the mean, standard deviation is 1. And for this area, you have a 0.17, which is going to be obviously called upper bound. Upper bound. Okay, but what's the lower bound for this area? Lower bound must be on the left. Do you guys see any indication that where the lower bound is going to be? See, there is none. There is none of the number on the left shows you lower bound. By the time you put the lower bound, LB as a negative 10 to the power 99 as a calculator. By default, put negative 10 to the power 99 as a lower bound because you don't see lower bound here. Okay, now let's put in the calculator. What are you going to put? Normal CDF. Okay, then you put the lower bound, negative 10 to the power 99, comma, upper bound. Remember that 0.17 is upper bound for this area. 0.17, what's the mean? 0, standard deviation 1. Put that in the calculator and let's see what you get. Again, you do second BRS, number 2, normal CDF. That's the function you're going to use. You put the negative, I should say minus 10 to the power 99. Remember that this is the minus, okay, comma, and 0.17, comma, 0, comma 1, close parenthesis. That's the area, 0.5674. But if you round it to 4 decimal, you get 0.5675, right? 0.5675. That's the area. Also call this the probability. And we call this like this: probability of z-score less than equals to 0.17 equals 0.5675. That's what we call in another way. Does it make sense to you? That's the another way we call this the number, which is area, same as the probability. This P, parenthesis, uppercase P, represent probability. Z less than equals to 0.17 equals that. Thus you find the first part A for this question number 2. For part B, it says 0.17 or more. Okay, there's two ways to do it. One way, you have to just, since you find the probability 1.17 or less, If you subtract from 1, of course you get the probability 1.17 or more. Okay, therefore here this is the right option. Here you can see that this area represent 0.17 or more. Okay, now what's the probability? Since you already find the probability of 1.7 or less, if you subtract from 1, you get the 1 minus 0.5675, you get 0.434325. Okay, this is the way you subtract the answer from part A to get the answer from part B, because in the part A you find the probability that this score will be less than 0.17, and you're looking for probability that this score will be 0.17 or more. Then you subtract from 1, because the total area is 1, right? If you subtract from 1, you get this part B answer. Okay, all right. Another way to do it using a calculator, if you want to do that. How you do it, just use upper bound, lower bound. Okay, for this area you're looking for this area, right? Another way. Okay, another way. For this area, what do you guys think? Upper bound, lower bound. Remember that this area goes to the right. You can see that. Therefore, this number here on the left is going to be lower bound. This is the lower bound. LB is 0.17. Upper bound to the right, do you know what's the number that bound upper? Nope, there is no such numbers. Therefore, upper bound you use here 10 to the power 99 is upper bound. Compare the previous one. If you have an area on the left, right? If you don't know the lower bound, then you put negative 10 to the power 99. Unlike here, you have area on the right, and you don't know upper bound, you put 10 to the power 99 positive. Now if you use a calculator, normal CDF, lower bound is 0.17, comma, upper bound is 10 to the power 99, comma, 0, comma, 1. Notice that this 0 and 1 is standard deviation, meaning it's standard deviation. If you put that everything in the calculator, let me put that for you, and you have to get exactly the same answer. Alright, let's do that. Second BARS, number 2, number CDF, and you put the 0.17 lower bound, comma, 10 to the power 99 upper bound, comma, 0, comma, 1, close the parenthesis and enter. You get 0.4325. That's how you do it. Now part C, of course you can finish yourself. Part C, you find the score between these two numbers, between 0.14, negative 0.14, negative 1.04. Therefore the right answer is going to be this one, C. And to find the area or probability, then use normal CDF again. And for this one, this number is lower bound, this number is upper bound, and put in the calculator and you'll get the answer. Okay, the answer must be 0.0684 if you round it to 4 decimal places. Okay, question number 3. There is 4 part of the problem, but I'll just do one part, and the other one is similar. Since I do one, you should able to do other one. Determine the area under a standard normal curve that lies to the right of this A. I'm going to do this, only this part here. Okay, therefore before I do that, if I make a graph, it's going to be easier. I start with the line here, I put the Z here. Why? Because it says standard normal curve, and that line must be Z line. Therefore, of course you have a Z value is given, and I put that as a curve, and I label this as 0, and I have a 1 here, I have a negative 1 here, I have a 2 here, I have a negative 2 here, like that. Correct? You don't have to do it, but if you do this kind of labeling, that's going to be easier for you. And what's the point you are looking for area on the right? Remember that you find the area to the right of every numbers, area to the right of that, right of this, right of that. Okay, therefore negative 1.68 is somewhere here. Let me label that here. This point here is, let me put negative 1.68. Okay, now you're looking for the area on the right. We are looking for this area. Okay, makes sense? You're looking for this area. All right, look at here, the shaded area here, which is yellow. That's where you're looking for. Make sense? Now if you find this area, you look for bound. For this area, this number must be, what do you think, upper bound or lower bound? Yeah, this must be lower bound. Lower bound. This number must be lower bound. What's upper bound of this area? I don't know. Okay, because this area goes all the way to the right. I don't have a fixed upper number that bound this, the yellow area. Therefore I don't have a upper bound. Then what's the upper bound if I don't have it? Upper bound, I don't have it, that means I put 10 to the power 99. Remember that that's what we did in the previous question, right? Here, see, doesn't have an upper bound here. We put 10 to the 99. And let me put that on the calculator. Of course, the mean here is 0. Standard deviation is 1 because standard normal curve always has a mean equals to 0, standard deviation equals to 1. I'm going to put that in the calculator. I'll come back. Okay, remember that in the calculator I put a normal CDF negative 1.68 here, this lower bound, comma upper bound 10 to the power 99, right? Because I don't have upper bound, therefore I have to put that. And mean gonna be 0 because if the standard normal curve, mean is always 0 and sigma is 1. And a close parenthesis, I press enter, I get 0.9535 rounded to 4 decimal. Therefore I get 0.9535. Similarly, you can finish all part B, C, and D because all actually find the area on the right of that z-score. Okay, if you like, you can make a graph and you can just finish yourself. Okay, question number 4, slightly different. Find the indicated probability using the standard normal distribution. Okay, it doesn't tell you right or left, whatever, but you know from the inequality you're looking for the area to the right because it's greater here. Therefore I suggest you always make a graph. Okay, this is the z because I'm looking for probability of z greater than 0.206 negative. Therefore I'm going to make it the standard normal curve. Remember that this point is the mean, which is 0, and negative 0.206, what is that? Negative 0.206 is somewhere here, correct? Negative 0.206. And I'm looking for probability. Basically I'm looking for the area to the right of this number under the curve. That means I'm looking for this area. Okay, let me make a side here. This area, I'm looking for this area. Okay, remember that this is z greater than negative 0.206. The probability is this. And again, to find the probability or to find the area, you're looking for lower bound, upper bound. And notice that this number here must be lower bound, right? LB, because you have the right area. On the left number is lower bound. What's the upper bound? Upper bound has a bigger number, but there is no such upper bound. By the time, upper bound must be 10 to the power 99. What's the mean? Mean is what? 0. Why? Because this is the standard normal distribution, and this z-score here, mean must be 0, sigma must be 1. And use the calculator as normal CDF again, like you guys did before. Let's put that in the calculator. Second VRS That's why you found normal CDF number 2, and you use lower bound here, which is negative 0.206, negative 0.206, comma, the mean, oh sorry, upper bound 10 to the power 99. Technically we didn't have it, therefore I'm going to put that, comma, 0, comma, 1. Remember that this is the mean, 0, standard deviation 1. Close parenthesis, press enter. That's the area 0.5816. Okay, this area is 0.5816. 0.5816. Okay, that's the question number 4. Question number 5. I'm not gonna finish it, but I'll give a hint for question number 5. Let's do A and B, C similar. Find the area between z equals to negative 0.16 and z equals to positive 0.16. Find the area that lies between. Okay, that means you're looking for area. You using normal CDF, the function, lower bound, comma, upper bound must be put in order, comma, mean, comma, standard deviation. Again, because this is the standard normal curve, the mean is always going to be 0, standard deviation is 1. Okay, for this part A, what is lower bound? Lower bound must be 0.16 negative, upper bound must be 0.16 positive. Okay, and put everything in the calculator, you get question number 5 answer. The answer must be 0.1271 if you round it to 4 decimal places. Okay, and do the similar for other one. Again, some of you might have a calculator like this. You put the lower bound, upper bound, mu, standard deviation, best. You get the same answer as this one. This way you do it. Okay, that's the question number 5. Question number 6. Determine the total area under the standard normal curve in part A through C. Okay, total area of, and what's the area for part A? To the left of z equals negative 1 plus, that means you have to add, to the right of z equals to positive 1. Okay, you got to find the area. Let me make a graph for you for A. This is the z-score on this line. This is called standard normal curve. Okay, that's 0, which is the mean, and 1 is here, negative 1 is here. And if you want to see the area on the left of z, which is going to be this area, left of z, you notice that, right? And if you want an area to the right of z, you're going to get this area. Okay, makes sense? This is the area right of z. This is the area on the left of z equals negative 1. Make sense? And you got to find this total area, because find the area under the normal curve of left of z equals negative 1 plus, right, to the right of z equals to 1. Okay, there is 2 ways to do it. One way, you find the individual area, this area and this area, and add them together to a total. Other way you can find this area, the middle area, find this area, find this area, and subtract from 1. Right? Then you get the yellow area total. That's what I'm looking for. That could be quicker. Okay, therefore let's find the middle area here. Okay, why do you find the middle area? To find the middle area, you find upper bound, lower bound. This is the lower bound for the middle area. 1 is upper bound for middle area. Notice that this is the lower bound, this is the upper bound for middle area, and mean is 0, standard deviation is 1. And I can do normal CDF, negative 1, lower bound, comma, upper bound, comma, 0, mean, 1 standard deviation. Let's find this area and subtract from 1. That's the answer. um, let me put that in the calculator. You can do, let's say, second VRS, number 2 normal CDF, -1 lower bound, comma upper bound 1, comma mean is 0, comma standard deviation 1, close parenthesis, and that's area. Okay, and if you subtract from 1, pretty much 1 minus 0.682689, whatever, you get 0.3173. Okay, that's what the area going to be. The final area going to be 0.3173. Make sense? Because I find the middle area, which is going to be 0.682689, right? And subtract from 1 to get the remaining area, which is the total. And the other one, part B, is slightly different. Let me make a part B. Part B is slightly different. You don't have to do that way because the area is not symmetric. For part B, find the area under the normal curve to the left of -1.57. Therefore, for part B, this is 0. -1.57 is somewhere here. Let's say -1.57, and to the left, that means you're looking for this area. Okay, this area, and to the right of 2.57. Therefore 2.57 is here, right? 2.57 here, and right of 2.57 is this area. Okay, therefore in this question you're looking for the this area and this area. Okay, how do you find this area and how do you find this area? Okay, to find this area you got to figure out upper bound. This is the upper bound. Let me write down upper bound. Upper bound. Lower bound here is 10 to the power 99, but the negative, let's just say -10 to the power 99. For this area, this is lower bound, 2.57. Upper bound is, we don't know, therefore it's 10 to the power 99 is upper bound. Since you have a upper bound, lower bound for each area, you find each area using normal CDF and add, and you'll get the answer for this combined area. Okay, and you can finish yourself. And part C is similar. Question number 7. Find the z-score. Here you got to find the z-score. All right, find the z-score. It says that the area under the standard normal curve to the left is 0.85. This is the area, left area. I should say left area is 0.85, and find the z-score. And if you make a graph, looks like this. This is the z-score here, and this is the standard normal curve, and that's the mean. And you're looking for the z-score. That means the point on this line where area on the left is 0.85. That means that point must be somewhere here. Okay, this is the point you're looking for. This is the z-score that I'm looking for. Looking for that z-score. And the idea is, the thing is, the area, this area here on the left is gonna be 0.85. See, the area here on the left, that's given. Make sense? Area is given. Actually, left area is given from that point, which is 0.85. Or 85% area is in this shaded region. And what is the point is going to be? Okay, and for that one you got to use other function called in norm. You got to put this in norm, find the left area from that point you're looking for, comma 0, comma 1. I should say mean and standard deviation. Mean, comma, standard deviation. That's the calculator function we're going to use. Okay, in norm, left area from that point that I'm looking for, mean, standard deviation. Okay, let's do that. Remember that I'll use the left area. Use the calculator here. In norm is same window as you'll find normal CDF. Let me go back to the second PRS. You see the in norm, that's number 3, in norm. Okay, click number 3, you get in norm. And here put the left area, which is going to be 0.85. You guys see that area under the curve to the left of. That means this must be the number you're going to put here as a left area, comma, mean is 0, comma, standard deviation is 1, close it. Okay, and you get answer 1.036, and it's rounded to 2 decimal places, going to be 1.04. Therefore the answer is going to be 1.04, and that means this point here is 1.04. On the left of this 1.04 there is 85% area belongs to, or 0.85 is area on the left of 1.04. Okay, and I want to point out some calculator has this option. When you click in norm, and this area, in this portion you put the area as 0.85 and mu as a 0, sigma as a 1, tail as a left, choose tail as a left. But some of them doesn't have a tail option. If the tail option is not given, always put left area if tail is not given. Okay, if tail is given, you can put the area and specify the tail, which area is in what direction. But if tail is not given, you always put area as a left area, okay, of that point you are looking for. Question number 8. Find the z-score such that area under the standard normal curve to the right is 0.26. Okay, this is same as question number 7. I should say similar, but it should say area on the left, but this area on the right. Okay, therefore if area on the right is given, what's the area on the left? Area on the left of from that point going to be 1 minus 0.26, was going to be 0.74. Okay, 0.74. 0.74, and then you use this number 0.74 in the function that we just did in question number 7. Therefore basically we are looking for area on the left of that point, and put in that function in norm. Okay, alright, question number 9. Find z-scores. There is 2 scores here because z-scores means plural here. There's 2 scores that separate middle 22% of the distribution from the area in the tail of the standard normal distribution. Okay, here's the thing. This is the standard normal distribution z, and that's the curve. Okay, and it says find z-scores, that means scores here, which separate middle 22%. Therefore I'm looking for pretty much these two points here. I should say this is z1, this is z2, and this middle area here 0.22 is the middle area. In other words, 22% of the distribution is in the middle. That means this area must be 0.22. Okay, if this area is 0.22, how much this area and how much this area? What do you think? Okay, you do that. 1 minus 0.22 is what? 0.78, right? And this 2 area total to 0.78, and since these are the half of 0.78, and half of 0.78 is going to be 0.39. Therefore this area is 0.39, this area is 0.39. Okay, you guys notice that the area on the left of Z1 is 0.39. Makes sense? Therefore I'm looking for Z1. To find the Z1 you use in norm. Remember that to find the Z-score you always use what? In norm. We just did it. To find the Z-score we use in norm. Therefore to find this Z-score, which is Z1, we use in norm. And what's the left area from this point? 0.39, right? Comma, mean 0, because that's the standard normal curve. Mean is 0, standard deviation is 1. Put that in the calculator. Let me go here. You do second BRS number 3 in norm is 0.39, 0.39 comma 0 comma 1 is going to be 0.27931, but instructions say round it to 2 decimal places. Is going to be negative 0.28. Is make sense? Negative 0.28. But this point is going to be negative 0.28. In other words, this point Z1 is negative 0.28. Okay, and what's the Z2? What do you think? Since these are the same distance from the origin, I'm sorry, from 0, mean, which the mean is here obviously. Therefore by symmetric, Z2 gonna be 0.28 positive, because look here, from this point 0, Z1, whatever distance is Z1, Z2 is the same distance in other sides. Okay, by symmetric, it's called symmetry. SYMMETRY. By symmetry, Z2 must be 0.28 positive. And how do you put the answer? You put the answer as remember that, use a comma to separate the answer as needed, round it to 2 decimal places. Going to be 0.28 negative comma 0.28 positive. That's the answer for question number 9. Question number 10. Question number 10 and 11 are the same. Therefore I just want to do one of those questions. Find the value of Z alpha. Remember that the symbols here, subscript on Z called alpha. I can name it ALPHA. We call this like this, alpha, and this is called Z alpha. And here alpha is the area under the right of the point Z alpha. In other words, here is the thing. If the line here, Z score gonna be here, Z score gonna be here. This is the standard normal curve, and this is obviously 0. And if this point, let's say this, if this area is alpha on the right of this point is called Z alpha. Okay, pretty much alpha is the area on the right of the point Z alpha. And the Z alpha is basically Z score. Okay, Z score or Z value, where area on the right of that point Z alpha is alpha. Okay, so this number here, 0.37 here, pretty much represent a right area from Z 0.37. That's what that represent, the number 0.37. Now let's answer this question number 10. Find the value of Z alpha, where alpha is area on the right of this point, and here in this particular examples alpha gonna be 0.37. okay, 0.37. Therefore I'm looking for the point on this line, G line, where area on the right of that point is going to be 0.27. And what do you think this area going to be on the left of this point? What do you think? Is going to be basically 1 minus 0.37. 0.37, which is going to be 0.63. I put this area here, let me color it. This area is 0.63. That means this is area on the left from this point that I'm looking for. Okay, now to find this z-score, we got to use in-norm option. That's why you used before, and again every time you have to use left area. Alright, therefore to find this number 10, use in-norm, and left area here is 0.63 comma mean 0 comma standard deviation 1. Notice that these are the two numbers, mean and standard deviation, second and third number under the in-norm. You put that everything in the calculator, you get that point. That's what I'm looking for, and round it to 2 decimal places. Okay, let's put it in the calculator, and here's a calculator. You put the in-norm. Let me just into in-norm here. Second VARS gives you this window, and number 3 gives in-norm, and put the left area 0.63, 0.63 comma 0 comma 1 close parenthesis. That's the answer, 0.3318, and here rounded to 2 decimal, going to be 0.33. Okay, question number 12. Assume that the random variable x is normally distributed with mean equals 50 and the standard deviation is 7. Oh, these are the information we have here. Compute the probability. Be sure that draw the normal curve which with the area corresponding to the probability stated. Therefore, in the first question, which area represent the probability here, and corresponds to probability x greater than equals to greater than 42. Then obviously this is going to be you can see that that's the answer is A here. Okay, now you are looking for the probability here of shaded area here, and okay, and you use normal CDF for in this area here. Lower bound is 42. Okay, 42 is lower bound. You see, greater than 42, that means you're going to the right. That means 42 must be lower bound. Upper bound is we don't know, therefore upper bound is 10 to the power 99, and mean is 50, standard deviation is 7, and use normal CDF. Upper bound, sorry, I put lower bound first, which is 42 comma mean, I'm sorry, upper bound is 10 to 99, mean is 50, standard deviation is 7. Put in the calculator, you get the answer for number 12. That's going to be 0.8735. You round it to 4 decimal places. Okay, you finish yourself using calculator. Question number 13, similar to question number 12, but you have less than equals to 47. You're looking for the probability of random variable x less than equals to 47. Okay, that's you're looking for, and here given is mean and the standard deviation. It's 55, standard deviation is 9. You can see the mean is 55 in every option here. For the first part, which of the following shaded region represent probability of x less than equals to 47? Obviously you can see that the graph B represent the probability x less than equals to 47, because this shaded area is less than 47. Okay, now find the probability x less than equals to 47. You got to find the normal CDF, and for this area 47 must be upper bound. Okay, upper bound is 47. Since your area on the left, you don't know what is lower bound, you don't know, therefore lower bound here LB equals negative 10 to the power 99. Okay, upper bound is 47, and the mean is 55, standard deviation is 9. Use normal CDF like we did before, you get this the area. which is same as probability of x less than equals to 47, the answer must be 0.1870. You can try yourself in the calculator, you get that probability. Okay. Question number 14. According to the medical journal, the distribution of the weight of newborn baby is approximately normal. Okay, here's the thing. Approximately normal. Therefore, we can use the normal distribution model in this problem. And those baby which distribution is normal, approximately normal, with the mean of 3380 gram, you can see here, and the standard deviation is 450 gram. Use the technology or table, we usually use technology, to answer the part A through C below. And let's first answer the part A. What is the probability that a newborn baby will weigh more than 3900 gram? I mean more than 3900 gram. We are looking for the shaded area which is on the right of 3900. Which one is correct? Here of course this is the 3900. This point is mentioned in the top, therefore B is the right answer for the first part. And this area represents the probability of the newborn baby weight more than 3900 gram. Okay. Part B, actually the not actually the same part A. And then as long as you find the area, find the probability that the newborn baby will weigh more than 3900 gram. Therefore here you're looking for probability of x greater than or equals to 3900, or this is the continuous random variable, doesn't matter greater than or less than. I can put greater than 3900 if I like, or greater than or equals to, but in normal CDF it really doesn't matter. That's what I'm looking for. And what do you guys think? To find the probability you have to use normal CDF, right? Then you need what? Upper bound, lower bound. Okay, what's the upper bound for this one? Notice that this is the area. Look, you are on greater side on the right of this 3900. How far right you don't know, and therefore this numbers must be lower bound. Lower bound is 3900. What's upper bound? We don't know. We put 10^99. And since we have a mean here, we have a mean here and a standard deviation here, and you can put in the calculator to find the probability. Let's do that here. We do second VARS, number 2 normal CDF. Again, you put the lower bound first, which is 3900, comma upper bound 10 to the power 99, comma mean is how much mean 3880, 3380, I'm sorry, 3380, comma standard deviation is 540. Okay, now 540, enter, you get 16.1677. okay, 0.1677. But if you see the instruction here, you got to write down in terms of percentage, not the probability. Make sense? Therefore pretty much probability is 1.1677. How much? Let me see. 167783, whatever, 83. That's the probability. But you are looking for the probability as a percentage. See the percentage sign here? When you change the percentage, you move the decimal to the right. It gives you 16.7783. But if you round it to one decimal places, this is going to be 16.8%. Therefore, in this box, you put 16.8%. Okay. For part B, similar, but you're looking for the percentage of baby born weight between 33,000 and 3,900 gram between. Okay, therefore what's the correct graph for this one? Between must be, let's find it, and this must be C. See, between 3,039 gram. Okay, and then next question, how much percentage of this area is? That's the question. And you do the same thing, use normal CDF in the calculator and use the lower bound as this lower bound LB 3900, upper bound, and of course mean is 3880, 3380, I'm sorry, standard deviation is 540. Use that in the calculator and you get the percentage must be 59.1% if you round it to one decimal places. Make sense? Part C. A baby is classified as low birth weight if the baby weight less than 2600 gram at birth. What percentage of newborn would expect the low birth weight? Select the answer graph below. Well, it looks like you have a graph is all together by some reason, but you're selecting the graph which looks like this, and you have this normal curve. X is here, the mean is 3380, and 2600 is somewhere here, and this is the what you look here. Select the right answer. This is the correct graph. Okay, that's what the graph looks like for part C. The first graph is this, and the question is, what percentage of the newborn expected to the low birth weight? That means you're looking for what percent of this area gonna be, or what is the probability of this area. Okay, or probability of this region. That's what I'm looking for here. And how do you find it? Remember that you use normal CDF. Use normal CDF again. CDF. And lower bound. Do you know what's the lower bound for this area? You remember that this is area on the left. Therefore, we don't know how far left it goes. Therefore, lower bound is going to be negative power 10 to the power 99. Upper bound is going to be this point 2600. The mean going to be 3380, comma, standard deviation is, you have it here, 540, and you use a calculator to find the area. Then you get the percentage, which is going to be 7.4%. Okay, therefore this pretty much area is 7.4%. In other words, 7.4% baby has low birth weight. Okay, makes sense? 7.4% baby has low birth weight. Question number 15. According to the recent reporting on a standardized test, the average math score of students in the particular state was 558. That's the average. Mean. Assume the scores are normally distributed with the standard deviation 96. Answer part A through C below using an appropriately labeled and shaded normal curve for each point. Okay, and first part of the question is, what percentage of the math test takers from this state score 600 or more? Therefore, you look for the normal graph here, and 600 or more is this is 600. This point is 600, and 600 or more is going to be this shaded region represent 600 or more. Therefore, you select the B. Because 600 to the right is more than 600. Okay, check answer. That's correct. You got to find this area and change to the percentage. Pretty much you got to find how much percentage is going to be this area covered by this area. That's what I'm going to find. Notice that you're looking for the area on the right of 600. Well, 600 must be lower bound. Upper bound must be 10 to the power 99. Let's use in the calculator normal CDF. That's what you use to find the area. And 600 is lower bound. Upper bound is, we don't have any, therefore we put 10 to the power 99. Comma, mean is 558. And the standard deviation is going to be 96. When you close parenthesis, you get this 33.087. What we rounded to one decimal, gonna go 33.087. 1. That's the answer. Okay, and you get it. Do the same thing for other one. What percentage of the math test takers from the state score between 600 to 648? Therefore, looking for the area between 600 and 648, and obviously this is the correct area. You see that this point is 600, this point is 648. Okay, check this graph, check the answer. Now you find the area, this area, how much this area gonna be. That means what's the area between these two score 600 and 648. To find the area, you have the lower bound 600, upper bound 648, and the mean standard deviation you have that put in the calculator. Now I'll come back after I put the calculator. Okay, I put this information in the calculator on normal CDF. Lower bound 600, upper bound 648, 558 is the mean, standard deviation 96, close parenthesis, enter. I get the area 50.1566. If you round it to one decimal, it's going to get 15.7%. Okay, as a percentage, you get at 15.77%. Okay, all right. Then you get the next question here. Suppose students who score top 5% in the state were eligible for the special scholarship program. What score would qualify the students for the scholarship program? Here, in this case, we are looking for the score, not the area. Here, 5% is top 5 score, represent the area above this point. Remember that this is the top 5%, represent this area. In other words, anybody who score more than this point gonna get the scholarship, and you got to find this score here. Okay, and the score, to find the score at the point on this line, you got to use in norm. Therefore, I'm gonna go to in norm, and I got to use the left area. Okay, but the right area is 5%, is 0.05. Left area going to be 0.95. Now notice that this white area is 0.95 as a decimal. Well, I'm going to use in norm, which is number 3 here, and I use left area, which is 0.95, comma, the mean is 558, 558, comma, standard deviation is 96. Okay, that's how you do it. Remember that. Just put this at the first number under in norm, gonna goes left area from that point we are looking for. The left area here is 0.95 because right area is 0.05. Okay, and enter. You get 715.90. round it to nearest integer, gonna go at 716 is the score. Therefore, what you understand here is to be eligible for a scholarship, the one has to score 716 or higher. Okay, and check answer. That's the correct. Okay. Question number 16. Assume that the random variable x is normally distributed with mean 50 and the standard deviation 7. Compute the probability here. Okay. To be sure, draw the normal curve with the area corresponding to the probability stated. For here, obviously you can see the area between 35 and 63 you are looking for, which is the probability, and obviously this is the right answer, which represent this probability. That's the area. Okay, that's the answer. And to find it, and remember that this use normal CDF with the 35 lower bound, 63 upper bound, mean 50, standard deviation 7. I'll put in the calculator and we'll be back. Okay, here I put the 35 as a lower bound, 63 as an upper bound, mean as 50, standard deviation 7 in the normal CDF, and I press enter. I get 0.95229. We round it to 4 decimal, we're gonna get 0.9523. That's the answer. Okay, remember that this area is 0.9523. Okay, check answer. Done. Next question. Fill in the blank to complete the statement. The notation G alpha, the symbol is alpha, is the Z score that the area under the standard normal curve to the right of G alpha is alpha. Remember that in the notation G alpha, this alpha is the right area from the point G alpha. Okay, therefore this alpha here, the symbol is area on the right of the point Z alpha. Okay, fantastic. And you can see in the explanation here, see, that's the point Z alpha. This area is alpha, which is right of the point Z alpha. Okay, next question. Question number 18. Okay, question number 18, and I draw the graph to illustrate that situation here. Okay, and find 78th percentile. What is 78th percentile on this situation here? And here's the graph for that. This is the standard, this is the normal curve, and this data is x here, mean is 50, standard deviation is 7. And we're looking for this point where area on the left of this point is 78%. In other words, this yellow area is 0.78. Therefore, this point is called 78th percentile. This point is called 78th percentile. Okay, how do you find the point here? This pretty much find this x value here. That's here. That's what it is. That's what is called 70th percentile. We use the in norm. On the left area is 0.78, comma, mean is 50, comma, standard deviation is 7. Remember that when you find this, the point on this line, when you know the area, you always use left area from that point which you are looking for, comma 50, which is mean, comma 7, standard deviation. Put it in the calculator. Let's do that. Second PRS number 3 is inner, and 0.78 comma 50 comma 7 close parenthesis. That's point here. 55.40 on the 2 decimal gives you 55.41. The 55.41, that's what we get, is called 78th percentile. Okay. Next question, number 19. Found that the mean amount of time car spent in a drive-through of certain fast food restaurant is 132.4 seconds. Assuming drive-through times are normally distributed with standard deviation 31, complete part A through T. Therefore, what I'm going to do here is, this is the time here, x, and the mean time here gonna given is 132.4 seconds. That's the mean, and the standard deviation is given as 31 seconds. Okay, that's the information. You have it. Okay, that's the question number, let's say 19. That's what I'm doing here. Now, what is the probability that randomly selected car will get through this student drive-through in less than 84 seconds? Here we're looking for probability of drive-through time less than 84 seconds. Okay, therefore pretty much you're looking for, this is 84 is, if you make a graph for this scenario, 84 is 132.4 here, 84 is here. Okay, this is the 84. I pretty much you're looking for this area. In part A, you're looking for this area. Okay, see, less than 84 seconds. Therefore, here you're using normal CDF. Lower bound is negative 20/99. Remember that there is no lower bound for this area. Use, because area is on the left, you put negative 10^99, comma, upper bound is 84, comma, mean is 132.4, comma, standard deviation is 31. Put that in the calculator. Let's see. I'll put it and come back. Okay, and I put that information here in calculator under normal CDF, and I enter it, get 0.059227, and round it to 4 decimal gives you 0.0592. Okay, 0592. That's the answer, and you're good. And here is a more than 179 seconds. That's another one. A similar question here. Here it says in the first part say less than 84 seconds. Second part say more than 179 seconds. Therefore 179 is somewhere here. Let me just draw. The 179 is, let's say, somewhere here. 179, and you're looking for this area. Okay, pretty much this area. And here pretty much looking for probability of X more than 179. By the time you just do normal CDF again. Okay, but here 179 is lower bound because you're looking for area on the right. The right, we don't know how far it is, therefore upper bound is not known. Therefore we use 179, comma, upper bound 299, comma, 132.4, comma, 31. Put that in the calculator and I'll come back. Okay, and that's the information I put in the calculator. Okay, and then let's press enter, and I get 0.06639. Round it to 4 decimal gives you 0.0664. Okay, 0.0664. Makes sense? And that's correct. And what proportion of the car is spent between 2 to 3 minutes in the restaurant drive-thru? Okay, 2 to 3 minutes, between 2 to 3 minutes. Therefore here we're looking for probability X between 2 to 3 minutes. Remember that this time here, the mean is going to be on the second, but here say 2 to 3 minutes. Therefore 2 must be in the minutes here, but we change to seconds. 2 minutes going to be 120 seconds, and 3 minutes going to be 180 seconds. Okay, remember that this is seconds. It says 2 minutes and 3 minutes, but we change to the seconds. Make sense? In other words, we are looking for the proportion of the car that is spent between 120 seconds to 180 seconds. Okay, in other words, this is the lower bound, this is the upper bound here, and we have a mean and standard deviation as given, and let's put in the calculator and I'll come back. Okay, I put that information in the calculator. One normal CDF 120, lower bound, upper bound 180. That's the mean and standard deviation. Press enter. I get 0.59308. If you run it to 4 decimal places, I get 0.5931. Okay, 85931. Okay, that's the answer. Okay, part D. Would it be unusual for the car we spend more than 3 minutes in the restaurant drive-thru? Why? Okay, more than 3 minutes. That means you're looking for probability that is more than 3 minutes. Here in this last question, you're looking for P X is more than 3 minutes. Okay, what's the 3 minutes again? 180 seconds. Okay, therefore we're looking for the probability more than 180 seconds. Remember that I use 180 as a bound. Remember that 180 as a lower bound because you are on the right of this 180. An upper bound is 10 to the power 99. We don't have that, therefore we put 10 to the power 99. mean and standard deviation are given. Let's put it in the calculator. Okay, and you're looking for the probability, but am I using in um, normal CDF? That's number 2, and 180 is lower bound. Upper bound is, I don't know, if I want to put in 10^99, comma, mean is 132.4, comma, standard deviation is gonna be 31. Okay, and I get 0.0633, 0.0623, I'm sorry, 0.0623. The probability that cars spend more than 3 minutes in the restaurant drive-thru is 0.0623. Okay, let me see, 0.0623, 0623, right, for decimal. It would be unusual, would not be unusual, since the probability is what? More than, greater than 0.5. Okay, remember that this is the greater than 0.05. This would not be unusual. Okay, and that's all. Greater than 0.5. Okay, and next question is finished. Question number 20. This is exactly similar to previous questions, and since you have a mean and the standard deviation, you're looking for part. Just let me give sketch for this question. Okay, I'm not going to finish it, but in the part A, question number 16, I'm sorry, question number 20, part A, you're looking for probability of x greater than equals to 62 hour. That's what you're looking for. Okay, part B, you're looking for probability. Remember, there's a proportion, which is same as probability, which 52 hour or less. That's what you're looking for part B. Again, use normal CDF, and you decided what is upper bound, what is lower bound, and mean and standard deviation are given. Part C, you're looking for probability of 57 less than equals to x less than equals to 61 hour, because the ball will last between 57 and 61 hour, and here 57 is the lower bound, 61 is upper bound, definitely. And finally, part D, you're looking for what's the probability. Here every time ABC it's a proportion, but here is a probability that randomly selected light bulb lasts less than 45 hours. Here looking for probability x less than 45. Okay, again, even if you put equals to, it doesn't matter, because it's a continuous random variable. It doesn't matter on the normal CDF. That's how you solve this question. Make sure you round it to 4 decimal places. Okay, I think you will finish by yourself. All right, question number 21. Okay, question number 21 is also similar to question number 20 again, because there is similar information given here as well. It says, hey, test score are normally distributed with the mean and the standard deviation. And the question tells you find the probability that randomly selected medical students who took a test that had a total score of that was less than 47. Therefore, in the first part, I just want to write the first part here. In the 20, part A, you're looking for probability of x less than 487. Okay, that's what you're looking for, right? And here you write your answer as a decimal, rounded to 4 decimal places. Use normal CDF again, because you're looking for the area on the right of this 487. A mean and a standard deviation are given. Okay, and you finish this question, and questions B pops up, and so on. You can finish all the question. Okay, this is similar to other one. I'm not gonna do that because I did this type of question a lot in previous example. Okay, question number 22. This is similar. I did 1 percentile questions. Okay, and I'm going to do this I think in this questions too. Okay, and here as long as question x to find the percentile, use in norm. To find percentile, use in norm. Okay, and that percentile, what is given is left area. That percentile that is given is left area from that point that we are looking for. Okay, that we are looking for. For example, in these questions, if you're looking for the 80th percentile, the 80th for part A, 0.80 is left area. Okay, and here mean is average birth weight is 3 ounces, therefore mean is 3 ounces, and the standard deviation is 0.6 ounces. And you're looking for in norm, left area 0.80, comma mean, comma standard deviation. Let's put that in the calculator. Second VRS, as we get number 3 is in norm, 0.80, comma 3, comma 0.6, close parenthesis. See, you get 3.504. Rounded to 2 decimals gives you 3.50. That's the 80th percentile. 3.50. Okay, what do you mean by that? That means 80% of the domestic cat birth weight is less than 3.5 ounces. Okay, only 20% is more than 3.50 ounces. 80% cat who born, domestic cat who has a weight 3.50 or less during the birth. Okay, that's what it means. Similarly, you can finish for 20th percentile too. The same idea here. You just put the 0.20 for part B. Okay, you finish yourself. Okay, that's all about this chapter 7, section 7.2 homework. Thank you for watching this video. Bye.